So, welcome to lecture 18 of the course on data structure and algorithm. In the last class, we discussed Polish notations of expression, algebraic expressions, which are being used in computers for evaluation of expressions. So, in the last class, we introduced conversion of infix expression into its equivalent postfix expression. So in today's class, we shall discuss about evaluation of a postfix expression, and then we shall understand how to convert infix expression into its equivalent prefix expression. Okay. So we already understood okay, how to convert infix into postfix expression. Now we shall be given a postfix expression and we have to evaluate it. Okay, so like we human being, if we are given an infix expression, we can readily very easily evaluate that infix expression to produce a single output. Okay, so let me throw you a question with the help of that example we can understand it, how to evaluate a postfix expression. So this question was appeared in the last year rescheduled class test 1. So the question was by applying the algorithm of postfix expression evaluation using stack, find the result of the given postfix expression. So it is as 12 comma 7 comma 3 comma minus comma so slash comma 2 comma 1, then 5, then plus, then star, then plus. So the commas are given to make you understand. Okay, so after 12, 1, if you don't provide comma, then it's an ambiguity that okay, just for your understanding purpose. So commas are used to separate the consecutive characters. So 12 is a character. Okay, 7. 12 is not a character. 12 is in this case. mm, uh, I mean uh, a value. The data. 7 is a data, or we can say 12 is an operand. 7 is an operand. 3 is an operand. Minus operator, like that. Okay. So yes, here 12 will be assumed to be a character, but it's not logically correct always, but it's a character. Okay. So right. So this okay. So in tabular format. So it was a 4 marks question, which was appeared in 2019, rescheduled fastest one. So show in tabular format. So I will show you how to write the answer, because we will understand the logic. Okay, but to properly write the answer, just follow how I'm doing. So you have to construct a table. Okay, so here construct a table. So here, okay, table of 3 columns. Okay, so in the first column, oh, okay, so in the first column, you will write character scan. In the second column, you will write stack content, and here intermediate results. So here, first 12 will be scanned, and stack content as I mean, as it's a number, it's a data. I mean operand. So it will be simply stored into the stack, pushed into stack. And intermediate result is nothing. So something like this, a dash hyphen we are providing. Next character scanned is 7. So it is again an operand. So stack content is, so 7 is pushed into the stack. So at this situation, the stack content is looking like this: 12 and then 7. So 7 is the topmost element of the stack, and still no intermediate result or status is produced. Next is another operand 3. So it will be simply pushed into the stack: 12, 7, and then 3, and here still no intermediate result. Next character is your minus. So as minus is an operator, so what will happen here? So first 3 will be popped out. Okay, then so popped out means it is being deleted, right? So 7 is 3 is deleted. Next 7 will be popped out, and 2 consecutive operands will be popped out. Okay, like this. Okay, so then minus means 7 3 minus, which is equivalent to 7 minus 3, that is equal to 4. So this is computed. So for 3 will be popped out, 7 will be popped out, and minus operation will be performed on those operands 7 and 3 to produce 7 minus 3 equal to 4.
Sir,
And
one
this,
question.
yes.
Sir, in this tag, the order is 7, comma 3. Then how come it, then in the intermediate result, then it will be reverse, no? 3, comma 7.
No. Huh?
Sir, sir, first we are popping
No,
out
no.
3.
This is not a stack. This is stack. So computation is done in this way.
Okay, sir, okay, sir.
Okay. So it's like if you are supposed to what is the postfix? So postfix means these two operands are following minus operator. That means 7 comma 3 comma minus. Okay, so 7 comma 3 comma minus. If I put here comma and then it will be fine. 7 comma 3 comma minus. So that means actually 7 minus 3 equal to 4. Okay, so this is not a stack. So here order is not a problem. But yes, the order in which you are popping out, that is important. First you are popping out 3, so 3 will be the second operand, and then 7 you are popping out, so 7 will be the first operand. Okay, so this is like subtrahend, this is like minuend. Okay, so 7 minus 3 equal to 4. That's why. Acha. So next is division operator. Okay, so as a result, what is happening? The after the 4 result is produced, this much sub part of the expression, I mean stack content is evaluated 7 3, and 4 is produced. So that 4 will be pushed into the stack. So this is the content. Okay, after completion of this step minus step. ঠিক আছে? Next character scanned is division. So again, what will happen? It will pop out 4. Okay. So it will pop out 4. So that is the second operand. And then what is happening? Okay. Then 12 is pop out. 12 is your first operand. Okay. And then division operator. So which is equivalent to 12 by 4, that is equal to 3. Okay, so that 3 is pushed back into the stack. So next comes 2. Simply it will be added to the stack, 3 comma 2. Then 1 is coming, no result here, no intermediate result. Next character is 1. Okay, you can see the result here. So next character is 1. So 1 will be simply pushed into the stack. So 3 comma 2 comma 1, and still no intermediate result. Next is a character, no sorry, 5 data is there. So it will be simply stored into the stack, 3 2 1 comma 5, and here no intermediate result. So next is plus an operator. So what will happen? 1 and 5 will be popped out sequentially. So first 5 is being popped, then 1 is being popped, and then plus operator, which equivalent to 1 plus 5 equal to 6. And that 6 is stored here. ঠিক আছে? Next, এবার আশা করি ঠিক আছে। আচ্ছা, তো নেক্সট ক্যারেক্টার হচ্ছে তোমার স্টার। স্টার। So 2 operands will be popped out. First 6 will be popped out. So 3 will be left only. So first 6 is popped, then 2 is popped, and then star operator. So which equivalent to 2 star 6 equal to 12, and that 12 is stored over here in the stack. Next, plus operator is there. So 2 operands will be popped, so simply stack will be empty, and then the first 12 and then 3, right? Oh, sorry. So then 3 and then plus. So which equivalent to 3 plus 12 is equal to 15. That is the answer. So 15 is the answer. Okay. The expression evaluation out
Sir,
is equal to, yes.
sir, why we are not writing 15 in stack content?
It's not required actually. It already that is popped out. Even if you write in the stack, that doesn't matter. I mean, you must write on that, no issue. Okay, so okay.
Okay, sir.
So as we are following a particular logic, so you can push back that result into the stack, and final answer of the stack, final content of the stack, we will retrieve and produce in the output. That's all. No issue. The expression evaluation output is then equal to 15. That is answer. So this is how we do postfix expression evaluation. Okay, and if you just convert back postfix into its equivalent infix and evaluate the expression, and hopefully you will come up to the same result, 15. Okay, so practice some examples from internet or some books, how to convert infix to postfix, and how to evaluate postfix expression. This is very, very important, very popular question. Okay. Next, coming to the next topic, which is infix to prefix expression conversion. I mean, this expression evaluation, infix to postfix, I mean, included in your laboratory syllabus. So that means in the next laboratory class, you have to actually practically implement this conversion, infix to postfix or infix to prefix, also prefix or postfix expression evaluation. Okay, so don't miss the classes. So video records are available for today. Okay, infix to prefix. So again, we will take the same example which we have used in the last class. Okay, so infix expression is given as 4 exponentiation operator 2 star 3 minus 3 plus 8 by 4 3 plus 3 8 by 4 by, then first bracket start 1 plus 1, that's all. Okay, so this is the infix. We have to convert it into its prefix equivalent. So again, we want to we have to actually impose some set of rules. So the rules are like very similar. Conversion rule are very similar to infix to postfix conversion, but one or two minor changes we have to do, but important. So this is the first column, character scanned. This is the action. So here, suppose a character scanned is a space, so simply you have to ignore that. So skip. Next, so if it is a digit or alphabet, simply you have to add that character into the target string, similar to what we have seen in case of infix to postfix. So we will do here target string, and also we will do see here the stack content. So digit alphabet, so added to the target string. Okay, pointed by a pointer T, for example. So next tree, if you see a closing parenthesis, okay, then it will be added to the stack using push function. This is exactly opposite to what we have seen in case of postfix conversion rule, right? So it was, if it was opening parenthesis, then it was added to the stack in case of postfix conversion. But this is opposite in case of prefix. Next is, suppose an operator is there, operator like exponentiation, plus, minus, multiplication, division. So that operator, okay, so what will happen? Firstly, the topmost element of the stack is retrieved, and then through and then through a while loop, okay, the retrieved operator character from stack, which is known as SOPR, okay, is compared with the character scanned, which is known as COPR, in terms of their priorities. And in that case, while comparison, two conditions we have to check. Number one, that is if SOPR is better than COPR, okay. So if SOPR is greater than COPR, then in case of SOPR, SOPR is at, okay. SOPR in that case, SOPR gets added to the target string. Okay, SOPR is added to the target string, and next COPR added to the stack. And second case, if SOPR is less than or equal to COPR, then SOPR is pushed back into the stack, and then COPR is also added to the stack. Okay, and then finally, if we have opening parenthesis, okay, in that case, I mean, operators present in the stack will be retrieved one by one using a loop and added to the target string till a closing parenthesis is encountered. Okay, so this is the complete set of rules. Yeah. Okay, so just one cross check, let me.
স্যার ওটা ইনফিক্স টু প্রিফিক্স হবে মনে হয় উপরে যেটা লিখেছেন।
হ্যাঁ হ্যাঁ হ্যাঁ, এটা পেস্ট ফিক্স। Okay. Okay, so this is the thing. Now, okay, so now let's take this example and see the intermediate results. Okay, then it will be more clear. Okay, so 4 2. So first character scanned is 4. So it's a operand, I mean digit or alphabet. So it is simply added to the, oh sorry, what will happen here, you have to do infixed expression, reversed infix. So in that case, first bracket close, then plus, sorry, 1, then plus, then 1, first bracket infix expression, then this, then 4, then this, then 8, then plus, then 3, then minus, then 3, then star, okay, then 2, then exponentiation operator, then 4. I guess all are correct. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 characters. 1 2 3 5 7 9 12 14 17 characters. Okay, so in this reversed order, first character scanned is a closing bracket stack as per the rule number 3. So in stack it is added. Next, 1. 1 is an data, I mean digit or alphabet added to the target string. Next, it's a plus operator. So firstly, topmost element of the stack is retrieved, and then through a while loop, the retrieved operator character from the stack. So there is no character left in the stack. So simply this loop is not getting executed. So what will happen? So simply the COPR is plus and SOPR is nothing. So COPR is higher. Okay, COPR is higher. So this case is satisfied. So SOPR is pushed back into the stack. That is first bracket close, and then COPR is also added to the stack. It is plus. Next 1. So 1 is simply added to the target string, then first bracket close. So when first bracket close is in scanned, so operators present in the stack will be retrieved, that is plus, using a loop. So there is only one operator, so only one time this loop will be executed. The plus will be retrieved, so it is popped from this stack, and that operator is added to the target string until the closing parenthesis is encountered. So closing parenthesis encountered, and at this situation, the stack content is empty. Next, division operator. So division operator, it's a, I mean again, it will be simply added to the stack because it's an operator and there is no already existing operator present in the stack. So simply COPR is division, SOPR is nothing. So this case is satisfied. Okay, so COPR will be simply added to the target string. Okay, that is division. What's up? This one. Okay. Next character scanned is 4. It is simply added to the target string. Next character is division. This is very important. Try to understand. Character in this situation, at this moment, scanned as division operator. Okay, so this is and this is your COPR. This is your COPR. Okay, and this is your SOPR. So COPR greater than equal to SOPR, equality holds. So this condition is again satisfied. So SOPR means division. This is pushed back into the stack, and then COPR is also added to the stack. So as a result, what will happen? Two consecutive division operators will be placed like this. Give a space. Right. Okay. Next 8. So 8 means it will be simply added to the target string. Next plus. Now this is another important thing. So plus is being scanned. So this is your COPR. SOPR is division. Okay. So topmost element of the stack, which is a division operator, is being retrieved. That is your SOPR. So a loop will be initiated. In the first iteration of the loop, this SOPR will be compared with COPR. So SOPR greater than COPR, right? So what will happen? This SOPR will be added to the target string. ঠিক আছে? So in the next iteration of the while loop, so this is popped. So next operator from the stack will be retrieved. That is your new SOPR. This is SOPR, right? And COPR is plus. So SOPR gets added to the target string. Okay, added to the target string. It is being popped out. And then the loop is terminated. There is no operator left in the stack. The loop is terminated. Okay, so that means what? This step is actually outside the loop. This is outside the loop. End while loop, and then you do this. COPR added to the target string. COPR added to the stack. COPR added to the stack. Okay, so this is the meaning. So when you will be implementing the code, then actually if we actually have a class, okay, another class, theoretical class, where we will do the algorithm development for these conversion policies, then we will be in a position to write the program code, right? So I just recommend all of you to actually go for the algorithm development first, and then you do the program code implementation. Otherwise it will be a mistake. Okay, so next okay, plus is done. Next is 3. So 3 will be simply added to the target string. Then minus. Okay, so minus has come. Yes, and so minus SOPR is plus, single operator present in the stack. COPR is minus, so they are having same priorities. So COPR greater than equal to SOPR, this condition is satisfied. So SOPR plus is pushed back into the stack. Also COPR minus is added to the stack. Next 3, this 3. So that 3 is simply added to the target string. Then star operator. The star operator, so you have 2 operators present in the stack, so a loop will be initiated. First topmost character, which is an operator, minus operator, that is your SOPR, that will be retrieved and compared with star. So SOPR less than equal to COPR, this condition is satisfied. Okay, so what will happen in this case? SOPR is pushed back into the stack, that is minus, and star is also added to the stack. So did you get the point? If this condition is satisfied, SOPR less than equal to COPR, Okay, so a loop has been initiated. There are two operators. That means that while loop can be executed maximum 2 times for these two operators, plus and minus. But if in some case, in the while loop, in some iteration of the while loop, if this condition is satisfied, what is happening? SOPR is pushed back into the stack. In this case, minus is the SOPR, is pushed back into the stack. COPR, that is star, COPR, that is star, is also get pushed back into the stack, and then simply you are done, you are completed. So you are not going for comparing plus and star. That means here we want to write an extra line. The loop is terminated. Okay, I probably yesterday I skipped this one two important thing. Okay, so similar rule is applicable for infix to postfix conversion. So this is very important, very close. Okay. So as soon as this condition is satisfied, you have to terminate the loop. But this condition, if it is satisfied, it will keep on going on the loop, next loop iterations. Okay, that is the difference in terms of program implementation. Okay, so this is the scenario so far. So next character is 2. It will be simply added to the target string. Then character is exponentiation. Okay, writing here like this, exponentiation. Exponentiation is having the highest priority. So this is your COPR. The first topmost element of the stack, that is star, will be popped, retrieved, that is your SOPR. So comparison, SOPR is less than equal to COPR. This condition is satisfied. So the loop is supposed to be terminated. And what will happen? SOPR pushed back into the stack, that is star. COPR is also added to the stack, right? And then loop is terminated. Okay, so exponentiation operation is done. Next 4 is there, so 4 will be simply added to the target string. Okay, yeah, target string. ठीक है, 3 3 2 4. Then all are done. This all the characters are scanned, completed. All their purposes are done. Now stack is, yes. We want to write a note over here, that is at the end there may be at least one operator present left in the stack. So they will be popped one by one and added to the target string, similar to what we have seen in case of infix to postfix target string. Okay, so you have to maintain the order. So first topmost element is exponentiation, so that will be added to the target string. So then star, then minus, then plus, and so that stack becomes empty. Okay, so whatever target string you have achieved, now do the reverse of that. Okay, so if I reversed target string, what will happen? Plus, then minus, then star, then exponentiation operator, then 4, then 2, then 3, then 3, then double slash, then 8, then 4, then plus, then 1, then 1. And this is your prefix expression. Okay, which is your reversed target. So this is your converted prefix equivalent form of the infix expression. Yeah. Okay, so I hope all of you have understood well. So with this, we want to close today's class, and there is a very small short quiz number 9. So I'm sharing, stopping my presentation and sharing the short quiz 9. So link has been given on the chat box. 33 students are present. In the time, let me take your attendance, and you start answering the short quiz. So it's 11:23. 4 questions are there. So 4 minutes. I think it's very sufficient. 11:27 will be the deadline. So ensure, submit the short quiz 9. Okay. Thank you.